You did math homework?
Yes, sir.
Okay. Okay, thank you. Iyanu, did you do the math homework? Iyanu?
Yes, sir.
Thank you. Now, starting from Iyanu, you know, we did page 47, practice exercise 9, 1A to J. Iyanu, what's your answer for 1A? The mixed number for 5/2. What was your answer?
Two and 1/2.
Correct. If that's what Joshua got, you're right. Now, B, what's your answer, Iyanu, for B?
One third.
Yeah, 1/3 or 1/3. What's your answer for C?
1/3.
Correct. Now, if that's what Joshua got, you're right. Now, let's go to Joshua. I want to ask for D to F. Joshua, your answer to D, 1D, 11/3 in mixed fraction. Joshua?
Sir.
Yeah. What's your answer? 1D to F. Yes?
Is it?
11/3 mixed number. Yes. What did you get?
I'm trying to work with.
What's your answer for 1D? Are you just doing it?
No, sir.
Tell me the answer. Didn't you do it?
Yes, sir. Yes, sir.
You didn't do it.
I did, sir.
Why?
He did.
Yes, tell me. Okay, let him tell us. Just see, Iyanu went straight to the answer. Joshua should do the same. What's your answer for 1D? 11/3. What did you get?
32/3.
You said what?
32/3.
Okay, Iyanu, what's your answer?
3 2/3.
Joshua, can you hear that?
Yes, sir.
Yeah, it's 3 2/3 is the answer. Joshua, what's your answer for 1E?
1/4/5.
1/4/5, correct. F, what's your answer?
2/1/6.
2/1/what?
6.
Correct, 2/1/6. Now over to Iyanu. I'm going to ask you G and H. Then I'll later ask Joshua I and J. Yes, Iyanu, G and H. What's your answer for 1G?
1G. 1 9 12.
Correct, 1/9/12. Okay. Age.
1, 6, 11.
Correct. Joshua, answer to I, 1 I.
My name is
Joshua.
yes, sir.
You said your answer to 1 I and 1 J, yes?
Mm.
Are you sure you did this homework?
Yes, sir.
What's delaying you from telling me the answer? Just once and for all. You are not doing as if you did it. Just tell me the answer. I didn't say you should calculate it. If I ask you, you should just go, I don't want to believe you did it. I'm not too sure. If you did it, you're supposed to be telling me your answer straightforward. 1 I. What is the answer for 1 I, Joshua?
4 fifths, 4, 5 over 7.
Okay. 1 J.
Yes.
Joshua is taking the advantage over me because I'm not God. If I'm God now, I will have been able to see into your paper whether you're just doing it or you have done it before. Oh my word. Yes, 1 J. What's your answer, Joshua?
4, 1.
What?
4 2 over 8.
You said what?
4 3 over 8.
4 3 over 8. Okay, we've tried. Okay, you got all the answers right. If that's what each of you was saying is what you got, then you are right. That's 10 over 10. Now let's go to the work of today. Before I take you further in other exercises, you know, we talked about lowest term, changing improper to fraction, changing mixed numbers, changing improper to mixed numbers, and changing mixed number to improper. That's exercise 2. We're going to do A, B, C together, and you will do the rest on your own. Now, number 2. Question number 2 says, change this to improper fraction. 2A says we should change 3 whole number 2 over 3 to improper. As we have learned the other time, that will be 3 times 3 plus 2 over 3. And that makes 11 over 3. 11 over 3. That is the answer to question 1D. 11 over 3. Then 2B will be 4 times 2 plus 1 over 2. And that will be 9 over 5. 9 over 5 is the answer to 1E. The answer to 4O number 1 over 2 into improper fraction is 9 over 2. Sorry, 9 over 2. That E is 9 over 5. Sorry about that. 9 over 2. Then C, change 5, 1 over 4 to, excuse me, change 5, 1 over 4 into that is 5 times 4 plus 1. That is 21 over 4. Excuse me. And that is how to change from mixed number to improper. Now let's look at question number 3. I will do 1, B, C. We're going to do it together. And you should go and practice on your own. Number 3, reduce these fractions to their lowest terms. Reduce.
Are you doing the math book?
I'm teaching you how to go about that. You know, we've done that the other time. So I'm explaining, and I want you to go practice on it. That's not homework. Is that okay?
Okay.
But your own leisure work, you know. Just do it. I'm not going to ask you as an homework, but I want you to go and do it. Is that okay? I can't give you too many homework at a time, because we're going to do another aspect of fraction today. On that new one, I'm going to give you homework. We've done practice exercise 1, 2, 3 in class. So I'm just showing you how to go about it. Is that okay? We talked about how to change mixed number, change improper to mixed number, changing mixed number to improper, and the lowest term. You know, we did those yet the other time. So I'm just doing it now in class, showing you how to go about it so that you too can go and practice on your own. If I would give you homework now, it wouldn't be on that we've done before. It's the new one we are doing today. Is that okay? So number 3, reduce this fraction to their lowest term. 3A, B, C. I'm doing that with you now in class. If I want to reduce 8 over 10 to the lowest term, I will just look for the highest common factor of 8 and 10. What number divides 8 and at the same time divides 10? The highest of them all will take it to the lowest term. Like 2 goes in 8 and it also goes in 10. And that's just those two numbers. 1 also goes in 8, 1 goes in 10. But the highest of both 1 and 2 is 2. So 2 in 8 is 4. Then 2 in 10 is 5. So reducing 8 over 10 to the lowest term will now give us 4 over 5. Now for 3B, the highest common factor between 12 and 16 is 4. 1 goes in 12, it goes in 16. 2 goes in 12, and it also goes in 13. 4 will go in 12 and 16 at the same time. Though 3 goes in 12, but it wouldn't go in 16, so you can use 3. So we're going to use 4. Out of 1, 2, and 4, 4 is the highest. So 4 in 12 is 3. 4 in 16 is 4 over 3. Sorry. 4 in 12 is 3. 4 in 16 is 4. So we have 3 over 4. 3 over 4. Now let's look at the C. 3C, 12 over 18. The highest common factor for 12 and 18 is 3. 1, 2, 3 goes in 12 and 18. Out of 1, 2, 3, 3 is the highest. 3 in 12 gives you 4, and oh, sorry, it's also in 12 and 16. 3 will go, sorry, 6 will also go in 12 and 16, not only 4. So we have 1, 2, 4, 6, and the highest of them all is 6. So 6 in 12 is 2. 6 in 18 is 3. So our answer for 12 over 18 to the lowest term would be 2 over 3. Now, did you understand all I've just done? In question number 2 and 3. So please go ahead later in your own leisure time, probably after class, go and do your practice on the other 2D to J and 3D to O. And please, if you encounter any difficulty on that, on those exercises, let me know. Now back to our work for today. We stopped at fractions in their lowest term. Now let's go into equivalent fractions. Equivalent fractions. Equivalent fractions. We're going to look at equivalent fractions and ordering fractions today. Okay? Equivalent fraction. From the word equivalent, it means fractions that have equal values. Fractions that have equal values. Now, equivalent fractions, they are built by multiplying or dividing the numerator and the denominator of the fraction by the same multipliers or divisor. Equivalent fractions are built by multiplying both the numerator and the denominator with the same multiplier, or you divide both the numerator and the denominator by the same divisor. What's a multiplier? A multiplier is a number you use to multiply another. Like if I say 3 times 2 is 6. 4 times 2 is 8. If you look at it, 2 is what I was using to multiply both 3 and 4. So 2 is a multiplier. 2 is a multiplier, the number, same number used to multiply others. Now, divisor. What is a divisor? Same number used to divide another. For example, I can say 6 divided by 3 is 2. And also, 12 divided by 3 is 4. There, 3 is the divisor. Now let's go into equivalent fraction exercise. It said, find other fractions which are equivalent to fractions 1, 2 over 3, and number 2, 56 over 64. If you go and check that book, the workout exercises there. 2 over 3 by multiplying. If we want to solve that, we will multiply 1, 2 times 3 over 3 times 2. You get the answer to be 4 over 6. You proceed further, use 3 to multiply 2 over 3. Whatever you get, you proceed further. You now use 4 to multiply. Is that okay? You use numbers in progression to multiply the same fraction, denominator and numerator, at the same time in the same order. So if we use 2 to multiply 2 and 3, we'll get 4 over 6. Use 3 to multiply 2 over 3. That is, you multiply by 3 over 3. That is 6 over 9. Use 2 over 4. You will have 8 over 9. If you look at it very well, we aren't changing the value of the fraction. We're just bringing the equivalent fraction. 2 over 2 equals 1. 3 over 3 equals 1. 4 over 4 equals 1. So invariably, we are not changing the value of the fraction. So whatever increase we're having in figure, fine, but the value of the fractions remain the same. So don't be confused by 4 over 6, 6 over 9, 8 over 12. If you take all to the lowest term, all of those 3 fractions comes back to that 2 over 3. Let's try it. 2 divided by 4 is 2. 6 divided by 2 is 3. So 2 over 3. Now to the fraction 6 over 9. You will say 3 in 6 is 2. 3 in 9 is 3. So that's 2 over 3. The next one, 4 in 8, 2. And 4 in 12 is 3. We see boils back to 2 over 3. Is that okay? So thus, the equivalent fraction of 2 and 3, the next 3 equivalent fraction will be 4 over 6, 6 over 9, and 8 over 12. Let's do one. 46 over 64. To do that, because they are large numbers, don't try to say you want to multiply. Well, you can if you start multiplying by 2, followed by 3, by 4, by 5, by 6, and so on and so forth. But the numbers you'll be getting will be larger, provided they didn't give you a certain specific order to go about it. You can as well make up your mind to divide. For example, we can divide by 2, we can divide by 4, and we can divide by 8 to get other equivalent fractions. If we divide 56 by 2, we will have 28. If we divide 64 by 2, we will have 32. So 56 over 64 can also be written as 28 over 32. You know, you're kind of, reducing it into the lowest term step by step until you get to the final stage. Now let's go to the second one. 56 divided by 4 and 64 divided by 4. You will need to divide by a number that can divide both the numerator and the denominator at the same time. 3 will not do that, but 4 will do. So 56 divided by 4 equals 14. 64 divided by 4 equals 16. Equals 16. So now we have 56 over 64 now can be written as 14 over 16. 14 over 16. If you look at 14 over 16, it can still be divided. It's not yet in the lowest term. So if we divide 56 by 8 and 64 by 8, we will get 7 over 8. Looking at 7 over 8, that is the lowest term. You can't take it any further, except you will have to write in a decimal fraction. If you want to write as a fraction, we'll have to stop at that 7 over 8. That's the lowest term. So 56 over 64, other equivalent fractions are 28 over 32, 14 over 16, and then 7 over 8 are the equivalent fraction. Any question? Yanu, do you understand all I've been saying so far?
Yes, sir.
Thank you. Joshua,
Yes.
do you understand?
Yes.
Thank you. Now let's go to the next one. Ordering of fractions. How can we order fractions? That is, how can we put fraction in their order of magnitude? Now, there are two basic ways to arrange fractions. You can arrange fraction in what we call ascending order of magnitude, ascending order. And the second one is descending order of magnitude. What is ascending order of magnitude? Ascending order of magnitude is when you arrange fractions or numbers starting from the smallest to the greatest. Smallest to the greatest. Smallest to the greatest. For example, to illustrate this, I don't know the kind of house you live in over there. Probably if it's a duplex, you're going to have a case in the house. If you live in a story building, then you have what we call staircase. But if you're living in a bungalow, there are no staircase in a bungalow, except probably if outside when you're coming in, it's a little higher above the ground. Then you can take about 2, 3, 4 stairs to come in. Do you understand? Basically, there are no staircase in bungalow building, except for story building or duplex. Now, let me illustrate with a staircase, assuming definitely you will have seen a staircase. Wow. You know, when you came to our country, when you came to our school in Nigeria, you know, you were going up the staircase cases and you're coming down. Is that okay? When you're going up the staircase, you are ascending. Is that okay? You start from the least and you climb up. So that is ascending order. Going up the staircase is an example of ascending. You're going higher, starting from the least to the topmost. Then the other one is descending order. You know, the moment they jingle the bell and you need to go home, you will go down the stairs. If you are going down the stairs, you're going to start from the highest to the lowest. That is descending. Going down the stairs is descending the stairs. Descend order. You are starting from the highest to the lowest. Is that okay? For example, if I have 1 to 9 as numbers, you know, we have, okay, let me start from 0. We have basically 10 digits that we use to form figures. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the 10 digits we use in mathematics to form figures from 0 to 9. So if I want to arrange 0 to 9 in ascending order, I will start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is ascending order. I've started from the least to the highest. Now, if you're going to arrange 0 to 9 in descending order, you will have to start from the highest to the lowest. You're going from up down. It's like counting backwards, counting backwards. So here I go, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, descending order. Now let's go into that example we have in the textbook. Example 5. Arrange these fractions in the ascending order of size, ascending order of magnitude. For example, it's going to be easy when your denominator are the same. The example we have here in number 1, the denominator are the same. So it's very easy to arrange that with less hassles, with less difficulty. Listen to the fractions. 4 over 7, 1 over 7, 6 over 7, 3 over 7. If you look at the value of this fraction, 1 over 7 is the least, followed by 3 over 7, then 4 over 7, and finally 6 over 7. So if I'm going to arrange 4 over 7, 1 over 7, 6 over 7, 3 over 7 in ascending order, that is, starting from the least to the highest, I will have 1 over 7, 3 over 7, 4 over 7, 6 over 7. Good. If I was also asked to arrange them in descending order, I'm going to start from the greatest to the least. So if I'm to arrange in descending order, 4 over 7, 1 over 7, 6 over 7, 3 over 7, then I will have 6 over 7, 4 over 7, 3 over 7, and 1 over 7. So I have successfully arranged 4 over 7, 1 over 7, 6 over 7, 3 over 7 in both ascending order of magnitude and descending order of magnitude. Let's go to the next one. We have to arrange 2 over 7, 2 over 3, 2 over 5, and 2 over 9 in ascending order. If you look at this fraction, the denominators are different. The first one we look into, the denominator were the same. They are all 7. They were all 7. But this time around, 2 over 9, 2 over 7, 2 over 5, 2 over 3. The denominators are 9, 7, 5, and 3. They are not the same. So the method of doing this will be a little different. Since the denominator are different, you will have to find what we call the LCM of the denominators. LCM of the denominator. LCM of the denominator. And how will you do that? Now, what is the LCM of 9, 7, 5, and 3? What does that mean? What number can I use 9 to divide, 7 to divide, 5 to divide, and 3 to divide at the same time? At the same time. I can only do that by looking for the LCM of 9, 7, and 3. What do you think that will be? Have you done LCM before? Yanu, Joshua, have you done LCM before?
Yes, sir.
Yes, sir.
So what is the LCM of 7, 9, 5, and 3? What number will 7, 9, 5, and 3 divide at the same time without any remainder?
63.
What?
63. What?
What will that be?
63.
Now, if you say 63, will 5 divide 63? Seven, 9, and 3 will divide to 3, but 5 will not. So what number will 5 divide and all of the other divide? Yes? Now, well, anyway, I just tried you there. If you look at the fractions we are dealing with, we have 2 over 9, 2 over 7, 2 over 5, and 2 over 3. Are the numerator not the same? Are they not the same? 2 over 9, 2 over 7, 2 over 5, and 2 over 3. They are the same, isn't it? The numerator are all 2, but the denominator that is different. In that essence, if you look at that, the highest number there is going to be 2 over 3, followed by 2 over 5, followed by 2 over 7, then 2 over 9. You don't need to look for the LCM. I was just trying to test you there. You don't need to check for the LCM. You just consider the numerator that are the same and look into their denominator. The higher the denominator, the lesser the value. Definitely 2 over 9, cutting 2 to 9 pieces will definitely be smaller than cutting 2 pieces will definitely be different. So the answer for that, if we are to arrange in ascending order, the answer to that the list will be 2 over 9. Is that okay? If we are to arrange 2 over 7, 2 over 3, 2 over 5, 2 over 9 in ascending order, our answer will be 2 over 9, 2 over 7, 2 over 5, and 2 over 3. Is that okay? Do you understand now? Good. And if we are to arrange it in descending order, that is starting from the greatest to the least, arranging 2 over 7, 2 over 3, 2 over 5, 2 over 9 in descending order, starting from the greatest to the least, our answer will be 2 over 3, 2 over 5, 2 over 7, and 2 over 9. Now let me give you an example of an exercise that you will need to look for the LCM. If you are given fractions like 3 over 4, 2 over 5, 2 over 3, 1 over 2, you will need to look for their LCM. The LCM of the denominator of 3 over 4, 2 over 5, 2 over 3, and 1 over 2. The denominators are 4, 5, 3, 2. The LCM is 60. Their LCM is 60. So you will just take the denominator to divide 60. 3 over 4, you will say 4 divided by 60 is 15. Use that 15 to multiply the numerator of 4, which is 3. Your answer will be 45. That is 45 over 60. For 2 over 5, you will say 5 in 60. Your answer is 12. Use the 12 to multiply the numerator, which is 2. So 5 over 6 will now be 24 over 60. For 2 over 3, you will say 3 in 60, and that's going to be 20. 20 times 2 will be 40. So 2 over 3 will now be 40 over 60. The last one is 1 over 2. You will say 2 in 60, which is the LCM. That is 30. 30 times 1, which is the numerator of 1 over 2, is 30. Now we have this fraction in 45 over 60, 24 over 60, 40 over 60, and 30 over 60. Now you see that we have made all the denominator to be the same. Finding the LCM of the denominator is like making all the denominator the same. You will now go and check the numerator. If you look at 45, 24, 40 and 30, if you are to arrange that in descending order, ascending order, the least is 24, followed by 30, followed by 40, then followed by 45. So if you want to write this fraction in ascending order, starting from the least is 24 over 60, and that is 2 over 5. So the first fraction will be 2 over 5. The next is 30 over 60. 30 over 60 is 1 over 2. The next fraction is 1 over 2. After that is 40 over 60. 40 over 60 is 2 over 3. So the next fraction will be 2 over 3. And the highest is 45 over 60. 45 over 60 is 3 over 4. So the last is 3 over 4. So arranging 3 over 4, 2 over 5, 2 over 3, 1 over 3, I think that will be 2 over 5, 1 over 2, 2 over 3, and 3 over 4. All have explained. Joshua?
Yes, sir.
Joshua.
Yes, sir.
Okay. Do you understand?
Yes, sir.
Yano?
Yes, sir.
Okay. Okay. Now let's try some exercises. If we look at page 44 of that textbook, you'll see past examination question exercise 9. Page 44, past examination question exercise 9. Question 1 to E. Question 1 says, what is the meaning of 2 over 5? Option A says 2 multiplied by 5. Option B says 2 subtracted by 5. Option 6 says 2 divided by 5. Option D says 5 divided by 2. And option E says 5 multiplied by 2. So what's the answer? 2 over 5 will be what? What's the answer? What's the meaning of 2 over 5? Whether Iyanu or Joshua, 2 over 5 means what?
It means 5 divided by 2.
Good. 2 divided by 5. It is 2 divided by 5. 2 divided by 5. That's the meaning of 2 over 5. And what's the meaning of 5 over 2? What's the meaning of 5 over 2? Joshua, what's the meaning of 5 over 2?
5 divided by 2.
Thank you. Now let's go to the next question. The next question says, change 20 over 3 to the nearest whole number. Change 20 divided by 3 to the nearest whole number. What they are trying to say is that divide it and take it to the nearest whole number. 20 over 3, that is 20 divided by 3. 3 in 20 is 6. 6 times 3 is 18. Take away 18 From 20, you have 2. So that will be 6 whole number 2 over 3. 6 whole number 2 over 3. If we are to take it to the nearest whole number, if you look at 2 over 3, 2 over 3 is almost 3 over 3. So you will change 2 over 3 to 1, add it to 6. That gives you 7. Is that okay? 20 divided by 3 is not actually 7, but 6 whole number 2 over 3 can be rounded off to be 7, because 2 over 3 is almost a whole number. So to the nearest whole number, 2 over 3 is nearer to 3 over 3 than any other type of fraction. Is that okay? So the answer there is 7 whole number. Question number 3 says, express 28 over 98 in its lowest term. 28 divided by 98. If you look at 28 divided by 98, the highest common factor there is 14. 14 will divide 28, and it will also divide 98. 14 in 28 is 2. 14 is 28 is 2. 14 in 98 will be what? Will 14 go in 98? Anyway, 28 over 98. Let's take it one step after the other. 2 in 28 is 14. 2 in 28 is 14. Then 2 in 98 is 29. So our lowest term would be 14 over 29. Sorry, 49. 14 over 49. 2 in 28 is 14, and 2 in 98 is 49. Is that okay? The lowest term there is 14. The highest common factor between 28 and 19. 28 and 98 is 2. Okay? Now let's proceed further. Number 4 says, reduce 144 over 180 to its lowest term. 144 over 180 to its lowest term. We can use 3 to divide 144 and 180. 3 in 144, you would just have to say 3 in 14 is 4. That is 12, remainder 2. So 3 in 14 is 4, remaining 2. So in 24 is 8. So 3 in 144 is going to be 48. 48. 3 in 18. 3 in 18 will be 60. So we now have 24 over 60. That is not the final answer because 2 can still go in 24 and it will also go in 60. Even 6 can go in 24 and in 60. 6 in 24 is 4. 6 in 24 is 4. And 6 in 60 is 10. Now we have 4 over 10. 2 can still go in 4 over 10. You proceed further. 2 in 4 is 2. Then 2 in 10 is 5. Our answer will be 2 over 5. 2 over 5. That's the lowest term. We could go on and on and on and on. Is that okay? We could go on and what? And on. Now I want to jump that exercise and go to number 9. In number 9, they said calculate the value of x in the equation x over 4 equals 42 over 4. X over 4 equals 42 over 4. You know, that's very simple. The denominator are the same. Can you see that? X over 4 equals 42 over 4. So if that fraction will have to be the same, then x will also be 42. 42 over 4 is equal to x over 4. For that fraction to be the same, x must have to be 42. Since the denominator is the same, the numerator will have to be the same. Do you understand that, Joshua?
Yes, sir.
Okay. Okay, that is it in mathematics for today. I would love to give you assignment. Please, our assignment will be taken from page 45. Page 45. We are on past examination questions, exercise 9. The questions are in page 44, 45 to 46. I want to give you that one in page 45. You will do question number 5. Do question number 5 to 14. Page 45, question number 5 to 14. Those are 10 questions. 10 questions in all. Past examination question exercise 9, page 45. Is that okay? If there will be any difficulty, look at that exercise and tell me which do you think will be causing trouble there. Let's briefly talk about it. Who has the textbook with him or her? Is it Joshua or Ianu? Who is holding the textbook? Ianu. Okay? Yeah. Can you see what I'm talking about? Page
Yes, sir.
45.
Yes, sir.
From 5 to 14. You see those ones in question 9 to 14. They are simple. All you need to do is what they call cross multiplication. To get x in number 9 is easy. I've done that for you. Since the denominator is the same, then the numerator has to be the same. What you need to do is you cross multiply. Use 4 to multiply 42 divided by 4. You get your answer. For question number 10, your x will be 27 times 5 divided by 45. Question 11, your answer will be just take any of those other complete fractions. Compare it with 49 over x. You can decide to take 7 over 8, or you take 21 over 24. If I take, for example, 7 over 8, that means my x will be, I will multiply 7 by x, equate it to 49 by 8. I will now divide both sides by 7. Now I will have x equals 49 times 8 divided by 7. Are you getting it, Yanu?
Yes, sir.
Good. That's how you roll. Is that okay? Do the same for others and you will get your answer. Okay? Planning to wrap up the class now. We have spent more than an hour. We're going to also 1.5 hours now. Any question from all that we've been doing for this week? Let's do a general review. What is it you want to ask question about? Or what do you want to add to all that we have been talking about so far? Yes? Any question, Yanu, Joshua? Yanu,
Yes, sir.
any question?
No.
Yes, what's the question? Okay. Joshua, any question?
No, sir.
Good. Now let me ask a few questions before we wrap up. Joshua, what soil? Joshua, what is soil?
What did you say, sir?
Joshua? I said, what soil? Soil. What is soil? We did that yesterday. What is soil? You want to check your book?
Okay, sir.
Okay, Yanu, what is soil? Are you checking your book? What is soil?
My book.
No, you don't need to check your book. You just have to say it. Now I will say it without checking. For me now, soil is the topmost layer of the earth, the top layer of the earth on which plants and animals grow and live. That is what soil is. And that is what we said the other time. I don't know if you have done type of soil before. I forgot to tell you that when we did it. Any of you can tell me the types of soils we have? Type of soil. One. Have you been taught soil before at school? Yanu and Joshua. Have you done anything about soil at school?
Yes.
Huh?
Yes.
Yes. Types of soil. Types of soil.
I don't.
Types of soil. Joshua.
Yes, sir.
Yes. Give me types of soil. One.
Mm.
Yeah, no types of. Okay. The two of you, please. Have you heard about sandy soil before? Sand. We have sandy soil. Have you heard about clay before? The word clay is clayey soil. That is, soil can be in three forms. In three forms majorly. Sandy soil, loamy soil, and clayey soil. Of all the three, the best for agriculture is loamy soil. Loamy soil, loamy is spelled L-O-A-M-Y, loamy soil. Sandy soil is sand, then you put Y behind sand. S-A-N-D-Y, sandy soil. Clayey soil is C-L-A. Clayey is C-L-A-Y-E-Y, clayey. Clay, clay soil. C-L-A-Y-E-Y, clay soil. And clay soil is what clay is what we use for molding. It's best for molding, best for culture. It's soil. Best for construction work is sandy soil. You use sandy soil for building houses, construction works, building concrete, building houses, building roads, bridges. Yes, use that for sandy soil. But when you're talking of agriculture, planting of crops, you will need to use loamy soil. That's what I expect for agriculture. When you are talking of molding of ceramics, pots, household utensils, and so on and so forth, you will need to use clay soil. You will use clay soil to mold. Is that okay? Any other thing you want to know or any question you want to ask? Do you understand what I just explained about types of soil now? Yanu, are you there with me?
Yes, sir.
Which of the soil is best for agriculture?
It was the.
What? You didn't write it down. Okay? Loamy soil is the best. You don't have the book. Okay. And you might have just jotted one side of that mathematics. So the loamy soil is the best for agriculture. Sandy soil is best for construction work. And clay soil is so so please do your God will be with you. Thank you for listening. Catch you next week. When you catch up tomorrow, remember to pray for me. Pray for me, pray for yourself, pray for your daddy and mommy, and pray for this, our online class, that will get better and better by the day. Both the hearer and the listener will get the best out of it. Is that okay?
Mhm.
If I remember, Yanu, your birthday is October 30. Is that it?
Yes.
Am I right? Are you going to celebrate it?
Yes.
Okay. So how am I going to get my share? No, I'm just joking anyway. I pray you're going to have a good celebration by God's grace. You and your friend will enjoy one another. So God bless you. See you on Monday. Bye for now. Regards to Eniola, regards to mom and daddy. So